Okay, so this is called intertemporal choice, and what we're going to try to represent on the two axes is consumption in period 1 and consumption in period 2, and we're going to measure C1 and C2 in dollars. Okay, so that means implicitly that the price of a unit of C1 is $1 and the price of a unit of C2 is in dollars. And we're going to suppose that the consumer is given M1 in period 1 and M2 in period 2. Okay? Now we're going to allow them to both borrow and lend at interest rate R. Okay? So that's the rate of interest. All right, and we're going to define savings as what you have left over after you've done your consumption in period 1. Okay, so savings is a choice variable, but notice that if you choose C1, then S is necessarily determined. Similarly, if you choose S, C1 is determined. So only one of those two is independent from the other. Okay, the other one is going to be dependent. Now let's think about what your consumption in period 2 is. Whoops, there we go. And your consumption in period 2 can be your income in period 2 plus what you saved and the interest on the savings. And we can represent that conveniently as 1 plus R times S. So note that this is just S plus R times S. That is, it's what you saved plus the interest on your savings. Now S can be positive or negative. If S is positive, then you are a saver. Okay? And if S is negative, you are a borrower. All right? But it can be positive or negative. Now what we want to do here is collapse these two constraints into one. So we want to turn S into M1 minus C1. We're going to make a substitution in here. And when we do that, we get C2 equals M2 plus 1 plus R times M1 minus C1. Now we can rearrange this a little bit, and it becomes M2 plus 1 plus R M1 minus C1 1 plus R equals C2. Okay? And this is equivalent to our y-intercept in this equation. Notice we've got the y variable all by itself on one side, and this is what? There's our x variable, and minus 1 plus r is what's multiplying against the x variable, so the slope is minus 1 plus r. Okay? So if we wanted to draw this into the picture, what would it look like? Well, we can allow C1 to be 0, that is, go all the way down here, right? And if C1 is 0, then we have a y-intercept of M2 plus 1 plus R M1. Okay? We also know that the slope is minus 1 plus R. So when we draw this, this thing is going to have a slope of minus 1 plus R. Sorry about the sloppy writing. Okay? I'll try this again. So the slope is minus 1 plus R. Okay? And we can actually figure this out, the intercept down here, by setting C2 equal to 0 and solving for C1. So if we set that equal to 0 and we solved for C1, if you do this carefully, you'll find that that's equal to M1 plus M2 over 1 plus R. Okay? That's what that intercept is going to be. So now, if you have specific numbers for M1 and M2, you can plug them in here and here. If you have a specific number for 1 plus R, or for R, 10%, for example, which would be 0.1. You could plug it in there. It would become 1.1, and that'll give you your whole line.